In this video, we will learn how to use stoichiometric conversions to determine the limiting reagent of a balanced equation and use the limiting reagent in order to solve a stoichiometric problem. So we are given this balanced equation: 2 butane plus 13 oxygen gas converted to 8 carbon dioxide plus 10 H2O. And we're asked how many grams of CO2 are produced when 1 gram of butane is allowed to react with 2.25 grams of O2 according to the following equation. So first we must determine the limiting reagent. So we take the grams of the reactants, which is butane and oxygen, and we convert those to moles. So we have 1 gram of butane given to us in the problem, and we divide that by its molecular weight, 58.12. And that gives us 0.0172 moles of butane. And we take the 2.25 grams of oxygen gas given to us in the problem, and we divide that by 32, which is its molecular weight, and we get 0.0703 moles of oxygen gas. So in order to find the limiting reagent, we divide each reactant's mole by its coefficient. So we take 0.0172 moles of butane and divide it by 2, which is its coefficient, and we get 0.0086 butane. And we take 0.0703 of oxygen gas and divide it by 13, its coefficient, and we get 0.0054 of oxygen. And then, because this is the smaller number, O2 is your limiting reagent. Now that we know our limiting reagent, we can convert moles of oxygen gas to moles of CO2. So we use our coefficients given to us in the balanced equation, and we have 8 CO2, and then we put that over 13 O2. And that equals what we're trying to solve for, which is moles of CO2 over the moles that we found earlier, which is 703. So the number that we found for our limited reagent, we don't use anymore. We're done with that. So we're just using the moles of O2. Okay, so X equals 0.0433 moles after we do our cross multiplication. So we have 0.0433 moles of CO2. So now we convert moles to grams. We multiply the moles of CO2, 0.0433 moles, by its molecular weight, 44, and that gives us 1.91 grams of CO2. Therefore, it takes us 1.91 grams of CO2. And that's your answer.